Good afternoon, everyone. My name is Joan Song, and today will be our first discussion session. Today we'll cover the project one, which has two parts, part A and part B. So I'm assuming most of you have started working on part A at least, right? Probably some of you haven't got a chance to look at part B, but that's totally fine. I think we'll get there soon. But first, let's talk about part A. And here's the specification of project 1A. So I think the thing you need to do is very simple. You just need to sort list of records. But the challenge here is that the records are variable sized. So it's a bit tricky to how to handle the data structure here. And also, you should write it in C language. So some of you should probably not with C. So that adds to the difficulty of this project. But as long as you get familiar with C, especially the pointer arithmetic, and also the struct, I think you will feel very comfortable with this part. Another challenge is that I'm not sure if you've dealt with the input file, output file that is binary files. I think normally we just take the text file, right, into our input, and our output is still a text file. And there is a very standard C library function to do this I/O. So I think basically I can show you here. So I'm not sure if you are familiar with the Linux command. This called man. It's short for manual. Enlarge it. Sorry. So this is a very powerful tool to see basically the menu of the C library functions. So for instance, I just now mentioned as before, it's like a reading input file that is normal, like regular text file. You can use like, first you need to open the file, right? We use fopen, right? File open, and you do this. You can see this is a Linux programmer menu. Very detailed explanation, including the method signatures, and also what you need to include when you need to use this function. And for each parameter, it has a very detailed descriptions. Right here, I think you should be familiar with here, like the mode, read, write, append, something like that.
A small thing for everyone for man.
Mm-hmm.
I don't know if this is a new thing, but when I've been running it off of the CS computers,
Mm-hmm.
it defaults to the BSD man page. If I want to get the Linux one, I have to do man 2.
Yeah, exactly, because there are a lot of like the naming is some crashes there, so you have to specify which one you are using.
We used the defaults last year to Linux, but
Okay, interesting, but never mind. So I think here we will. I think Gerard tomorrow will talk about a very important idea of system call. Right? For system call, it's the number for menu is 2. So every time you look up a system call function, you need to. I'm not sure if it's default or not, but make sure you have 2, and then you will always get a system call. So, but for fopen, for this example, it's not a system call. However, in this project particularly, we have the read, right, and also write, and also open. These 3 functions are just system call. And if you try to man like read, yeah, it defaults to the system call we're using. But for some other cases, there are other functions or command that has the same name with the system call. Then probably there will default issue. But just in case, every time you can try to use man 2 and read to make sure that you are looking at the system call. Right? So here, read is a system call we are using to do the project 1A. And here, it's very different from another C library function, which is fread, right? So here, I think probably most of you are more familiar with fread, which takes in the pointer and the size of the byte you want to read, and also the file object. But for this project, we're not using fread. We just use the read system call. So the first argument is a bit tricky. It's an int called fd, and you can see the explanation here. So it's okay here. So fd represents the file descriptor, but I'm not sure if you guys are familiar with this term. So this is nothing but an integer. It corresponds to the system call of the IO read write. And how did you get this file descriptor? You just every time you have before you read, you have to open, right? So you see the menu page of open. You'll see the return value is an int, right? It's an int, and it actually returns a file descriptor. Right. So open returns a file descriptor, which is a small non-negative integer for use to in a subsequent system calls like read, write, even lseek. Right? We don't use lseek for this part. So our main concern is the three system calls: open, read, and write. You see, they all have the 2 in the parentheses. So 2 here is not the argument for read or write. It just means it's a system call. 2 means system call in this manner. Okay, so here read parentheses 2 means read is the system call. So it returns a file descriptor, and there are like 3 file descriptors that's kind of reserved. So they are 0, 1, and 2. For 0, it means the standard input. For 1, it means standard out. And for 2, it means standard error. So every time you open a file using the open system call, the smallest number you will get is 3, because 0, 1, and 2 are reserved. So let me just have a demo here. So in order to use open, you should include all these guys, okay? Sorry. So let me try to make a demo here. So let's call open.c, for instance. So we should also include everything here. These are just the thing we need to include to use the system call, and it will return a file descriptor, right? And open. Okay, so I don't have a file here. Probably I'll just copy the sample in, for instance, into demo. Oops. Okay, we have the sample in as our input file. Okay, now let's try to open. So the first argument is actually a string called sample in. Okay, the second is a bit tricky. Let's look at the open again. So the second argument flags, it's an int. So what are the flags? Okay, the argument flags must include one of the following access modes. So what does access mode mean? Do I have an idea? So it's kind of like the permission of the file, right? So if you guys have already done the worksheets, I think the third question, right, the persistency is something about the permission here, right? Okay. So it's essentially taking the flags. So the first one, the R underscore RDONLY, it's actually representing the read only. And here it's write only, and here is read or write. So if you set, you open a file that is read only, but you try to write something to that file, you'll get an error. Basically, you'll get a set fault, which is the notorious C error, right? Every time you get a seg fault, but yeah, we'll talk about later. Though. Okay, so you better try to use the read write. That is the easiest way to do that. So you can both read or write. But for some specific circumstance, probably need to try to use read only. Right? But right now, you can for this project, you can just use read write as a access mode. In addition, we also need to make sure that because if the file does not exist, then we essentially, when open, we should actually create it first, right? So there's a flag called ocreate, which is used very often. And if you want to try to append, you will use otruncate. Sorry, no. Append is for append. Truncate, I think it's for overwrite. Overwrite the file you're writing. But for now, you just have the O read write. And also the O create. There's no E here, it's just O create. Okay, so let's try if it compiles. So how to compile it? You use GCC, and this is the name of the executable. Okay, good. Okay, nothing happened because I didn't have anything output yet. It's just to test if this is correct. Okay, now let's try to print the file descriptor. FD. So it's compile it again and open. So it should be 3 because 0, 1, 2 have been reserved for standard in, standard out, and standard error. Okay. Okay. With this, okay. What if? Okay, let's. What if I don't create? I just read write and like sample out. Because currently I only have the sample in. I don't have a sample out. What if I try to open sample out but without the ocreate tag? What will happen? Compile it first. Anyone have a guess? So, not particularly, not an error.
Can you go back to the thing?
Sure.
FD will not equal 1 or E0.
I mean, if opened successfully, FD should be 3 at least, because 0, 1, 2 are reserved for. So essentially, we'll get. Let's try. So forget -1. Okay. So every time you get a file descriptor that's -1, it means the file does not exist. So, but it will not terminate your program. Okay, it's not like a seg fault. So every time for sanity check, you will also try to assert FD greater than 0. And assert, to use assert, you have to include.
Question related to this part of the lab.
Sure.
Suppose the out file couldn't open or whatever, or runs into issues at any point, right? If we check it multiple times, then different message, or should we use the same messages for the file?
You mean the out when you write the output?
Yeah. If you can't get a file descriptor on the output.
Probably you would just throw file not found.
Okay.
Yeah, I think assert is if not again if you are not sure where what to include when you use assert, again you can use the menu. I'm sorry. I'm not. Yeah, I'm continuing the discussion. Sorry. So assert is just to include the assert knowledge. So let's compile it again, and assert failed, and then you will get this is essentially just terminates the program because the file is not found. Okay. Okay, so let's go back to sample in, and now let's try to read something from it. Okay. So let's again, before we use read, let's just take a look at the read again. So read essentially takes 3 arguments. The first one is file descriptor. Second one is the buffer, the pointer. What is this buffer? Anyone have an idea?
That's where you're reading the file into. So that's where the data is going to be stored.
Right, exactly. So basically, when you got a file, you open it, you read something, you must want to store the read data to basically to the memory, right? So buffer just holds the memory that you will get access to. So essentially, you are just okay. Then another tricky thing is that because sample in is a binary file, right? So what type do you want to store in this buffer? So it can be like the car, right? Or an int. Yeah, so that's kind of tricky. So if you do know nothing about the input file you're reading, actually you cannot determine what type you are choosing here. So for this project, in the samples, the input file are just a bunch of numbers, right, integers. Then you know, okay, I need to use this buffer as an int to hold or to store the data. But if you do not know it, you somehow use the character to store the data, then you will get probably just a bunch of garbage because the type is not consistent. Okay, so every time you read in the file, you have to make sure that what on earth you are reading, so that the type matches what you are storing here. Okay, so we know that it's just a bunch of integer, so we just use int to hold the buffer, and then is that if you just okay, let's try that. Okay, now we call read and taking the file descriptor and the buffer. Okay, the third argument is actually just the size of how many bytes you want to read. Okay, so say like I just want to read the. Oops. Periodically. So is this pace okay, or I'm speaking too slow? I mean, it's too detailed. You already know that, or that's totally fine. Or
It's good for me. I'm new to this.
Okay.
So this is
Yeah, no, there's a kind of a difference or gradient. So yeah, that's okay.
I mean, it was off when we got here, so that's flaky in that sense.
If there's other rooms that down that way that you could move to if it's weird. It's really like that.
Well, it's shutting down, and then we'll see if it boots back up.
Almost there.
Oh, is that a thing?
Oh, it's
It just takes like 2 minutes to shut down and then you have to do it.
Really all of them are using it.
Yeah, no, I was forgetting about the auto thing.
I think that was an honest.
Power efficiency.
It makes sense, right?
Same
Same
as
thing.
Yeah.
No, yeah.
And it's only in the nice rooms. It's not in all the.
5 minute break.
Yeah, 5 minutes. I'll probably